Myself Sai Prasad, Alexan, Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths B. We started our discussion with the chapter Circles. We have completed almost all different concepts of circles in our previous sessions. Today we are going to start a simple topic, that is how do we find the direct common tangents to our circles. Okay, till now we have discussed how do we find the common tangents, how many tangents do we have, yes, and also we have found out the common tangents and the common points, yes, and here we are going to find the direct common tangents. Okay, what are they and everything we will discuss. So, what will be our first step? Tell me, whenever we do common tangents or a pair of circles, we have to find centers and radii first. Shall we? See here, for the first circle, what is the center? For the first circle, center is minus 11 comma 2, isn't it? What is center of second circle? 11 comma minus 2, right? Then what about the radius of the first circle? 121 plus 4 plus 100, yes. What about the radius of the second circle? That is 121 plus 4 minus 100, is it? So, it will be R1 is equal to 121 plus 4 is 125, 225, 225 square root is 15, R2 121 plus 4 is 125, 125 minus 100 is 25, square root of 25 is 5. Okay. Now, find what is C1, C2. C1, C2 ka distance under root 11 plus 11 is 22 square, minus 2 is minus 4, which is 4 square, which is 484 plus 16, that is root 500. Okay. Whatever it might be, let us wait. So, you can write R1 plus R2 as 20, that can be written as 400, isn't it? So, from this relation you can tell that root 500 is more than root 400. So, therefore, C1 C2 is greater than R1 plus R2. So, what can we tell? How many tangents do we have? 4 tangents, that is first circle, second circle, this distance and this distance is more. So, we will have 4 tangents, that is 2 direct tangents and 2 transverse tangents. Okay. So, therefore, circles do not touch each other. Yes. So, we have to find the common tangents. How do we find? Is, let us assume an equation, that is, let y equal to mx plus c be the common tangent. So, can I write it as mx minus y plus c equal to 0? Yes. So, and let us assume this as equation 1 and this as equation 2. Clear? Now, we are telling that let this be the common tangent to both the equations. So, I can tell this equation is a tangent to this and this. So, equation number 3, see here, equation 3 is a tangent to 1. What is the condition? R equal to D? Yes. So, I can write it as R is equal to D. Okay. That is, for this equation, I am telling that this R1 is nothing but D from this point to that equation. What is the point here? C1 minus 11 comma 2, right, and what is the radius? 15. Yes, shall we do? See here, that is, what is R1? You can take anything, either 1 or 2. If you feel that this 15 is heavy to solve, you can take this 5 also. You can directly change here 2. What is the center here? 11 comma minus 2. Anything is okay. Okay, let us take 2 only. Fine. What is R2? 5. What is D? Perpendicular distance from C2 to equation 3. Yes, what is the perpendicular distance? Under root of ax1 plus by1 plus c by under root of a square plus b square, isn't it? So, m into 11 minus 2 plus c by under root m square plus 1. Yes. So, what is the equation here? Mx minus y plus c is equal to 0, right? So, let us simplify this. What do we get? 5 into under root m square plus 1 is equal to 11m plus 2 plus c. Yes, let us take it as equation number 4. Okay. Similarly, we know that equation 3 is tangent to equation 1. Okay. So, let us do the same thing for that also. 15 is equal to mod m into minus 11 minus 2 plus c by under root m square plus 1. So, we can write it as, let me write it here itself, this will be 15 into under root m square plus 1 into, I mean that is equal to minus 11m minus 2 plus c. Okay. So, if you observe here, this equation and this equation can be solved. Yes. So, let us subtract these both equations. Let us do 5 minus 4, we will get it as 15 minus 5 is 10 under root m square plus 1 minus 11 that is minus 22m minus 2 that is minus 4, cc will get cancelled. Is it done? Did you understand? So, we can solve this in order to find the values of m. Okay. Can I take minus 2 common here? So, I will get it as 5 into under root m square plus 1, that is equal to, after taking minus I will get it as 11m plus 2. Clear? So, let us square on both sides here, square on both sides, then we get it as 25 into m square plus 1 is equal to this minus 11m plus 2 ka whole square. How much is it? 121 m square plus 4 minus 11 2s are 22, 22s are 44 m. Okay. So, let us bring all to 1 together and subtract. 121 minus 25, how much is it? 96 m square, and here it is minus 44 m. Okay, and this is plus 44 m and minus 25. 4 minus 25 is 21. Is it right? Anything difficulty? No, right? Next, and check whether we can do any term common. No. Okay. So, let us directly factorize it. Just tell me the factors of 96 and 96 into 21. That is 96 ka factors is 24 3. I mean 24 into 4, right? 21 ka factor is 7 into 3. So, 24 into 4, okay, you can do, or else like do like this, 27, 24 3s are 72, 4 7s are 28, 72 minus 28 is 44, done. Okay. So, let us write it as 96 m square plus 72 m minus 28 m minus 21 is equal to 0. Let us take 24 m common here, I will get it as 4 m plus 3 m, 4 m plus 3, and if I take minus 7 common, I will get it again 4 m plus 3, here 4 m, here plus 3. Okay. So, I will get the values of m as 7 by 24 and minus 3 by 4. Okay. Use the two, I mean use the two values of m and we can find the values of c here. Okay. Then bring those m and y and substitute in the equation. Is it clear? Did you understand? Now let us substitute these m values in these equations in order to get the values of y, and here we have modulus here, do not forget. Okay. For solving the value of m, it is okay, because however we square on both sides after that. So, we will use modulus now and we will find the values of c here. So, let us substitute m is equal to 7 by 24 in this equation. What do we get? We get plus or minus 5, let me take, we have solved for plus, right. Let us take minus under root m square plus 1 is equal to 11m plus 2 plus c. Okay. So, let us substitute the value of m here, minus 5 into 7 by 24 is 49 by 576. Okay, again 576 LCM, it becomes 625, which is 25 by 24, that is equal to 77 plus 48 plus 24 whole divided by 24. I have written directly. So, from this what can we write is 77m, sorry, here it is only 77, right. What is 77 plus 48? That is 125, and here it is minus 125. So, I can write 24c is equal to minus 250. So, c will be minus 250 by 24. Okay. Let us substitute this value in the equation, that is y equal to mx plus c. What is m? Therefore, mx minus y plus c equal to 0. In that, m is 7 by 24x minus y minus 250 by 24. Therefore, it will be 7x minus 24y minus 250 is equal to 0. This is our equation of tangent. Clear? This is by using 7 by 24. What about this slope, that is minus 3 by 4? Let us substitute the same thing here. I will get it as minus 5 into m square, that is 9 by 16, that is 9 plus 16 by 16, that is 25 by 16, which is 5 by 4. Okay. That is equal to minus 33 by 4, okay, plus 2 plus c. What it is now? 4 2s are 8 plus 4c. Okay. So, 4 4 will get cancelled, here it is minus 25 and here it is 8 minus 33 is again minus 25 plus 4c. What about this? Here we will get c as 0, or else let me take only plus here. So, we will get it as c is equal to 50 by 4. Let us substitute the same in this equation, that is mx minus y, that is m is minus 3 by 4x minus y plus 50 by 4. Therefore, my equation will be minus 3x minus 4y plus 50 equal to 0, that is 3x plus 4y minus 50 is equal to 0. This is one equation and this is one equation. Okay. Other than this, you can also get an equation with constants as zeros. Okay. So, we can have this kind of direct common tangents. Is it clear? Is it okay? What did we do? First, we will find C1, C2 and R1 and R2. We will check whether these circles have DCT or not, that is direct common tangents. Then we will find, we will assume an equation and we will tell that that equation is a tangent to one of the circle. Then we will find the value of m and c. Okay. After that, again we will substitute these values of m and c in the assumed equation. Okay. Fine. Shall we move on to the next question? Let us do. Look at the next question here. Find the transverse common tangent to the circles given. What is the first we have to do? the same thing, we have to find the centers radii. Okay, see here, let us find centers first. What is C1? 2 comma 5. What is C2? Minus 2 comma 3. Is it? First center is 2 comma 5, second center is minus 2 comma 3. What is radius R1? Under root 4 plus 25 and minus 28. What is R2? 4 plus 9 minus 4. Therefore, R1 is 29 minus 28 is 1, R2 is 3. Okay. So, let us find the value of C1 and C2. C1 C2 ka distance is under root minus 2 is minus 4, 4 square is 16, 3 minus 5 is 2, 2 plus is, this is root 20. Is it right? So, now tell me C1 C2 is root 20, and what about R1 plus R2? That is 4. Okay, R1 plus R2 is 4. Let us write it as square root of 16. Which is more? Obviously C1 C2 ka distance. Therefore, C1 C2 is more than R1 plus R2. Is it right? So, we can directly write it as both the circle doesn't touch each other. So, again the same process. Let y let us find the point of similitude. How do we find? Let us find P which divides C1 C2 in ratio R1 is to R2, that is 1 is to 3. Okay. So, let us directly substitute and find the value, that is mx2 plus nx1 by m plus n comma my2 plus ny1 by m plus n. This is m and this is n. Okay. So, the point will be 1 into x2 plus 3 into x1 by m plus n, mx2 plus nx1 by m plus n. Do not get confused, check again, mx2 plus nx1 by m plus n comma my2 plus ny1 by m plus n. Okay. So, it will be minus 2 plus 6 by 4, 3 plus 15 by 4, that is nothing but 4 by 4 is 1, this is 18 by 4, that is 9 by 2. This is my point. I have a point. Let us assume m as a slope. Let m be slope of common tangent. So, the equation will be y minus y1 is equal to m into x minus x1, isn't it? So, let us write it in the form, that will be 2y minus 9 is equal to 2mx minus 2m. So, that will be 2mx minus 2y minus 2m plus 9 is equal to 0. 2mx minus 2y minus 2m plus 9 equal to 0. Check again and again. Y minus 9 by 2, that is y minus y1 equal to m into x minus x1. Here 2y minus 9, 2 is LCM. If I send this that side, that will be 2mx minus 2m. Okay, and here 2mx minus 2y minus 2m plus 9. Clear? Now, if we observe, this is our equation 1, 2, 3. 3 is a equation for both the circles, that is 3 is a tangent for both the circles. So, let us assume equation 3 is a tangent to equation 1. So, what is the condition? R is equal to D. Okay. What is the radius for the first equation? 1, that is equal to mod. Let us substitute in this equation. So, that will be 2m into 2, 2m into 2 minus 2 into 5 minus 2m plus 9 by under root 4m square plus 4. Yes, ax1 plus by1 plus c, that is minus 2m plus 1. The point is 2 comma 5 and the radius is 1. Is it done? So, let us cross multiply and simplify. that will be if I take 4 common, okay, let it be 4m square plus 4 under root is equal to 4m minus 2m. How much is it? 2m. 9 minus 10, that is minus 1. Clear? So, let us square on both sides. If I square on both sides, I will get it as 4m square plus 4 is equal to 4m square plus 1 minus 4m. This both will get cancelled. I will get it as 4m is equal to minus 3. I will get m as minus 3 by 4. Is it right? Did you understand? This is the value of m. Now, we have to substitute in this value. I will get directly the equations of tangents. Shall we substitute? See here, m is equal to minus 3 by 4, and one more thing, remember, we will have two transverse common tangent, but we got only one slope. We can't even take mod to that side, and because however we are squaring on both sides. So, let us assume one more slope be infinity. So, let us find the equation for both the conditions. See here, substitute in this equation, anything is fine. Okay, this is easy to solve. So, let us substitute it here. Y minus 9 by 2 is equal to minus 3 by 4 into x minus 1, and y minus 9 by 2 is equal to infinity into x minus 1. So, LCM is 2y minus 9 by 2 is equal to minus 3 into x minus 1 by 4. 2 1s are 2 2s are, that will be 4y minus 18 is equal to minus 3x plus 3. This will be 3x plus 4y minus 21 is equal to 0. And what about this? This is 1 by 0, therefore x minus 1 equal to 0. These are the both tangents to the circle. Clear? Once again, transverse common tangents are, how do they look? They cut each other in the cross direction. So, first we have to check whether the circles touch each other or not. So, we have to find C1, C2, R1 and R2. Since it is greater than R1 plus R2, obviously we can tell that both the circle does not touch each other. So, we can tell that they have transverse common tangents. So, in order to find that, we will find the point of contact, that is internal center of similitude. At this point, we will assume a slope and we will write the equation, right, and we will tell that this equation is a tangent to one of the circles. From that, we will find the values of m, and substitute in the equation, we will get two transverse common tangents. Clear? Hope everything is clear. What all we learned in this chapter? We started with the basics of circles. We learned how do we find the center and radius of a circle, then finding the equation of a circle, tangent. We learned about pole, polar, right. We learned about the pair of tangents, the angle between tangents, okay, and finding a normal, chord of contact, length of a chord, yes, and we started with this common tangents, direct common tangent, transverse common tangent, yes, is it okay? And how do we find the tangent? Yes, that is common tangent, point of contact. Clear? These are the basic topics of circles we have learnt in this chapter. Clear? Fine. By this problem we can end the chapter circles. Okay. Hope everything is clear for you. Let us meet in the next session with the new chapter of circles. Thank you.